Hi, welcome to the IntroStats lecture series. And we started this unit is testing hypothesis. And for the lecture number 4 and number 5, we finished hypothesis testing for the population proportions. So lecture number 4 is one population proportion test. And then the lecture number 5, we talk about the two population proportions test. And when we did these two lectures, we said, okay, let's assume our model will use the z-test, right? So we talk about the z-test, and then we talk about the critical values, and also we say, hey, how to use the, the TI-84 calculator to find the p-value. So now we say, okay, for the lecture number 6, we are going to take a detour from the testing hypothesis because we kind of know what is the testing hypothesis about. And then we continue to talk about this z-test, p-value from the z distribution. So what is that? So now, before we talk about the next testing hypothesis topics, we take a detour and take a look at what is this, we call it the Z, or we call it the normal models here. And what is the standard deviation as ruler means. And then after this lecture, you will get a pretty good idea what we talk about is the Z-test and the p-values, how to find the p-value if you have the Z-test statistics. Okay, and we're going to divide this lecture into several videos because this will be a pretty long lectures here. Okay, so now let's go ahead to go to our lecture notes here. Okay, before we start, so the first things, we need to introduce some terms, and some of this you maybe will hear again. So the first things here, we're going to talk about one very important, we say is the mean. Okay, so the means here, that means if you use a term everybody can understand, that's basically you can say, hey, it's the averages, right? So if you say average, I think everybody know that. How do I find the average? I just add the names together and then divide by how many I add, right? So this is the average. We call it, it's a fancy statistic term. We call it is the mean here. And then we say we always have, we call this the population here. Okay. And also we call this the samples here, right? Okay, so the first, let's take a look at what is the population mean. So the first things here, be careful the notation. We said the parameter population, we call this a parameter. So we use the Greek letter. So this is we call it mu. Looks like U, but the pronunciation we say is mu. So mu is what here? The mu is just like we know the averages, right? Mean. That means you add everything together. So that means as summation, the xi, right? Then I divide it by n. So I call this the capital N. That means it's all the number in the populations, right? And then this notations here, some student will get so scared. What is this one? This is what we call the summation signs here, right? So basically, this is so this notation here, this is basically, we call this the summation. Okay, so this is a summation. That means you add all the x here in this population, right? So they add everything here in the population and divide by it. And that's what we call this the population mean. And we use the notation what mu to represent it, right? So do not get confused that. Okay, now for the sample mean. So what is the sample mean? We know the sample mean, like we talk about the mu corresponding. So we say this is x bars, right? So we use the letters x bars here. And then the X bars here, just the same thing for your sample. And then you add all the sample value xi to now divided by the little n's here. Because the sample, I'm just taking a part of your populations, right? So that's how do we define the mean. We have two ways. So is it the average or, so it's the average, so either the population or the sample, okay? So now, what is the variances here? So average, everybody, I think probably everybody get a good idea what is the average mean. So what is the variances here? Before I write it down, the variance, I like to find, I like to, use some example to show you what is the variance, like the meaning of the variance, why we need to know the variance here. So for examples in here, so let's just use a very, very simple examples. I have 3 professors here. Okay, so I have 3 professors. Okay. Okay, so we have a professor number 1, and we have a professor number 2, and we have a professor number 3 here. Okay, and then I have these 3 professors. Now I have 2 students, and let's assume, these 2 students, they have the kind of the similar backgrounds and similar like knowledge. Okay, so professors teaching methods here. Then, after these 2 students, then the professor give them a test. So both are, let's do extreme cases, right? So both of the students get a 60, okay? So both of them get a 60. What is the averages here? For these 2 students, the average, so 60 plus 60 average is what? Is 60. It's correct. Okay, now for the professor number 2, and the professor number 2 have a different, these 3 professors, they have a totally different teaching method. Maybe one is just reading out from the PowerPointer, one is like give the certain, certain different way for these 2 students. And now let's take a look at the professor number 2 here, right? So professor number 2 here, those, they do the same thing and give these 2 students the test. Then let's say here, the student we have is like 40, let's say is, let's see here, we give a test and then these 2 students, I got 50 and 70s, all right? So for the 50 and the 70s, and then you take a look at the average. What is the average? Still is 60s, right? So it's 50 plus 70 is still 60. Now let's take a look at professor number 3 here, right? So professor number 3 have a very extreme different teaching methods here. So let's see here, professor number 3, then give the test to these 2 students, and I got a 30 and 90. So this is what? This is 60 also, right? So, if without, so like in here, let's see here. So if the people, okay, so let me try to do this. So if people say here, okay, if without looking, take a look here. If without looking the raw data, if the people just tell you, hey, these 3 professors with these 2 students, they have to, so seems they have the same impact because the student, the average of the class is 60, 60, 60 here. And then it seems I say, oh, wow, based on this, it seems these 3 professors, they have no different in their teaching methods here, correct? But now, if you take a look in here, if you look at I'm sorry here, all right? See here, back here, right? Okay, but if you do look at the raw data, see here, well, I do see what? I do see the differences here, correct? Okay, so for example, see here, so the like here we say, okay, all the three of them give me what? Give me the average 60s here, all right? And but the first professors, the way they teach here, the first professor's way, the both of the student at 60, 60. So there's what? Do I have any variations? No variation, correct? So I don't have any variation because they have the same grade. Then for the professor number two, see here, let's take a look. Professor number two, I got what? I got a 50 here, and I have a 70. So I have one student here, one student here. So what is their total variation? So this is their total variations, right? 50 to 60 and 70 to the 60. So this is how much they variate from the means here. And now, if you take a look at the third ones here, right? So professor number three, I have one student is 30, and I have other student is what? It's 90. Obviously, these two students have a big variation, correct? So you will see here from graph here, I say, oh, this student, both of them, they have a big variation to the means here, all right? So that's what I try to assess is how much is this differences like this ones and this one and this one. So like for the professor number three, I know the variation inside the data set is quite big. And but professor number two, the variation inside the data set, like in here, right? So this is their variation. So it's not that big, right? So there are some variations, not that big. So understand this concept. Now you will see, okay, now here is how do I define the variances here. So I say, I want to capture these variations, right? So the first thing is here, let's see the population, the variances here. I use the notation sigma square, okay? So the sigma square, so what is this one here? So the basically is here, take a look at these professor examples, right? We want to assess the differences from each individual to the average, each individual to the averages here, right? So that's why my formula is look like this. X minus what? Xi, so each individual Xi minus the mean, right? Then, in order to prevent the differences when you add them up, they cancel each other because this is like a 30 point below, this is a 30 point above. So if you 30 plus negative 30 will be 0. So in order to prevent the add up to the 0, so I kind of square that, right? So this one here still is I add all the way to the end. So this is, we call it the ends here, right? We divide by how many points in the population. And now, okay, so now let's take a look. How about the samples here, right? Is the sample, the variance we say is the S square. Okay, instead of using sigma, I use the alphabet, I call it the S square. So what is the S squares here? You still the same things, you add up the differences for each one minus what? Instead of minus mean, instead of minus mu, I'm minus what? I still try to find the mean, I minus x bars right here, right? See here. So then I still squared it. And then here is from, you add all the way up, how many samples in here. Now in here is very important here for the sample variance, instead of divided by, the n, I'm divided by the n minus 1 here. And later, you will learn the reason why we say we lost degrees freedom. But in here, let's don't worry about it. Let's kind of take this for granted and say, let's just try to remember this is as a formula. And the reason why it's n minus 1 is because in here, right, you already use one of them. So like here, the x bar values here, right? So the x bar value is you already use the statistics here. So that's why it's x bar and the sample is n minus 1 here. So this is a statistic. So like in here, the sigmas here, because it's mu and you know, it's a parameter. So that's why you don't lose degrees freedom there. But anyway, so if you do not understand that part, that'd be fine. And so that we just said, okay, the sigma, you know, the variances here is n minus 1, okay, for the sample, right? For variance, doesn't, you know, that's not a change, it's there. Okay, so what is the standard deviation? So we know still from this graph of your grade. So we still just want to assess the differences between each individual value and the mean. And the reason why we square that because we want to prevent when you add them up, they disappear, right? So the true variations here, so the standard deviation is just the sigma. It's just is what? You just take the square roots of the sigma square. All right. So the same way as here, this is just the square roots of the s squares here. All right, so that is what we call this a simple standard deviation. So sometimes you will say this is a simple SD here, okay? That's just standard deviation means here, okay? So that's what they are, the two most important, you know, those are the two most important measurements here, right? So statistics here with the mean and the variances here. Okay, now the next thing here, we're still in the definition stages here. We want to define, we call this Z-score. Wow, we start to kind of the, you know, give you the word like here, the Z-scores here, right? Z, so definition of, okay? So let's take a look. What is the Z-scores here? Okay, so for the Z-score, let's still do population and also let's do sample. And so in here for the populations here and the Z, we still use Z here. And then this one will just be whatever you have the value is Y minus. You can use Y or X, it doesn't matter, right? So let's try to use X. Maybe you guys feel better about that. So it's just your, whatever the value, you minus your mean, you divide by your standard deviation. So for the population, it will just be X minus mu and the sigma, right? And then for the samples here, you also call the Z-score. So it will just be still the X value. Then instead of minus mu, what do you minus here? You minus X bar. Then what do you divide here? The sample standard deviations here. Okay. Okay, so if you look here, the key characteristic is a very of the Z-score is very, very good. All right. So now the first thing is here. Okay. So the key characteristic number 1. Okay. So we call this is Z, the standardized values, right? So the Z-score, okay, values have no unit. Okay, so like when we measuring, so for example, I measure your weight, my unit is a pound, right? and measure how much time we spend to study, the unit is a minute, correct? Or the hours, right? So those units here. And so like for the drug, we measure how much, we call it milligram or the different measurements. So the units here, but the Z-score has no unit. So it's not say, so if X is the weight, so if the weight minus, the average weight divided by the sigma, it doesn't mean the Z-score is some type of the weight. No, the Z-score have no unit. It's because of Z-score is no unit. That means it doesn't matter what the things I'm measuring, I can have a comparison. I could be able to compare, right? Okay, so now what is the Z-scores here? Okay, the Z-score, so they measure the distance, okay, of each data value, okay, from the mean. Is from the mean in standard deviation. If you look at the formula, it's x minus x bar divided by s. So like in here, so let's see here. So if this is the one, okay. So if let's use the, let's use the sample. If this is x bar here, right? So, like from here to here, if I said the differences here, this is 1 sigma, right? That means this will be x bar plus s, right? So this distance here. And then here, let's see here, that means if here, the distance here, the red one is 2s, right? So that means here, this is x plus 2s. Okay, so now the corresponding lines here, right? So if you do the corresponding line here, so you see here, so this is x bar, right? X minus x bar, so it's a 0. Okay, so this one go to 0. Then this is x bar plus s minus x bar divided by s. What is this one give you? This one give you 1. And what is this one give you? This one give you what? Give you 2. So that is what we mean the Z-scores here. Right? So it's how many standard deviation from the center, right? So the Z-scores right at the center is 0. This is 1 standard deviation, so Z-score is 1. This is 2 standard deviation. This is a Z-score is 2. So the same way, if you go the backward, so like in here, right? So this is x bar minus s, right? So this is what? This is the 1 standard deviation below. And then the same way in here, you will say, hey, this is a 2 standard deviation. So it's x minus 2s. So what is your z-scores here? You will get a -1 and what? And -2 here, right? That's what is the z-score means, right? It's very, very important. So the z-score is the measure, the distance, right, from the mean. And in the standard deviation, that means if z-score is 1, I mean, I'm from the mean, 1 standard deviation, okay? And then the number 3 is here, the key characteristic about the z-score. So we know the negative z-score, what that means? That means your data value is below the means, right? So like in here, we have -1, -2. That means your data value is below the mean. Then if in here I have a positive z-score, if I have a positive z-score, that means the data value is what? Is above the means here. Okay, so this is quite important. So let's highlight the key things here, right? Negative, that means below the means, right? And the positive, that means above the mean. So it's right hand side, left hand side. Z-score is measure what? The distance, right? From where? From the mean in standard deviation. That means how many standard deviation away from the means here, right? Okay, so now let's take a look at why we want to use the z-score. It has some benefit here. Okay, so the standard value, okay, so this one's here. So we say the the z-score, okay, convert their original value, their original unit to the standard unit, to the standard, okay, unit of standard deviation from the mean. So that means right now, we all say, instead of say, what is your average? And you say, oh, my average is 95. Then we all say it's it's how many standard deviation away from that. Okay. So now the number 2, this is really important, right? So because of that, so we can compare, okay, values that are measured on different scale. Okay, all right. So like in here, for example, if you have, you are taking for example, the English test. Okay, so your teacher say, okay, and 100%, the English test. So for this unit, the top grade, all right. So the 100% is 60 points. And then you take the biology test. So the biology test, oh, I only have 2 problems. So I would say that for this test, the point is 20 points. If you get every problem correct, you got a 20 point. For the English test, if you got every problem correct, you got a 60 point. All right. So now if you say, okay, I got here, I have 48 points in my English test, and then I have 16 points on my biology test. So compared to the whole class, which one I stand better in the class? If the teacher try to curve, and where in the curve I am, right? So that's why, in here, because we have a different grading, so English test grading is 60 points if you get every problem correct, and the biology is like a 20 point, right? So that means if you get everything correct, you got the 20 points. So how do you compare 48 is better or 16 is better? That's why if you can find the z-score, and then you can compare, right? So if the higher the z-score, that means you are away from the averages. That means you are getting better, right? Of course, if it's negative, you also is away from the average. That means you are on the bottom 10. Then that's not good, right? Okay, now let's take a look here, right? So let's take a look at the first example by using this examples here. All right, so here it said that every year a national achievement test is the element in the third grade. The test has a mean score is 100 and the standard deviation is 15. If Jenny's Z-score is 1.2, what was her score on the test? Okay, so we know the Z-score is how many standard deviation away from the means, right? So the mean is 100 and I am 1.2 standard deviation away from the means here. So that means 1.2 times 15 away from the mean. And because Jenny's Z-score is positive, that means I know I'm above the mean, so I'm adding here. All right, so now this will be the 100 plus what is here? Plus 1.2 times 15, you will get 18. So this is 1/18 here. So that's what is this answer here. That's what is we talk about is the Z-score, right? So the Z-score is how many standard deviations away from the means here. Okay, so now we're going to stop at here for our first video, talk about the Z-score. And then we're going to talk about in the next video is how to put this Z-score together with the normal models here. Okay, so remember the key things, right? So basically this is the key things, right? Z-score is how many standard deviation from the mean. If you got a negative, you are below the average. If you are positive, you are above the averages here. All right. So one of the very, very good things here for the Z-score is what you can compare, right? Especially they are measured on the different scale, right? Because the typical we want to compare apple to apple, right? But if they measure in the different scales, how do you change the apple-orange comparison to the apple to apple? By using what? By using the Z-scores here. All right, that's it. And so this will be pretty easy videos. And so the next one, we're going to talk about normal distributions here. Okay, bye.